The next loop we're going to discuss is the for loop. The for loop is a count-controlled loop in the sense that a for loop always runs a specified number of times. There are no open conditions on a for loop. Let's start out by looking at the general form of the loop. As we start, I'm going to define LCV as loop control variable because I'm going to use that abbreviation here in a couple of places. The for loop begins with the keyword for, followed by an open parenthesis. Then, the first thing we do is we initialize a loop control variable, followed by a semicolon. Then, perform a relational test on the loop control variable. And then follow that, we modify the loop control variable in some way. And I'll explain how all that works in just a moment. Then we have an open brace for our loop body. And then we have our statements. And then we have our closed loop. So clearly all of the work other than for the processing is done in what we'll call the heading of the for loop. Because this general form doesn't give you very much of a clear understanding of how a for loop works, let's look at a very simple example. First of all, we will do the same program we ran when we first looked at while loops. We're going to display hello world 5 times. So we'll start out with the for loop. So we begin with the keyword for, and then an open parentheses. Now we're going to initialize our loop control variable, and we're going to name it I, very simple name, and we're going to initialize it to 1. And then our relational test is while I is less than or equal to 5. Our modification of the loop control variable will be to increment it by 1 each time. So notice how compact the for loop is. We get most of our work done in these 3 very simple statements. Then we open the body, move over underneath it, and we're going to write system out print line hello world, and then close the body of the loop. And that's all we have to do. So let's compile and run this program. So we'll save it. Java C chapter 9 part 5.java, and then Java chap 9 part 5, and there's hello world 5 times. So for each value of I from 1 to 5, we perform the statements in the body. In this case, it's displaying the phrase hello world. So I will get values from 1 to 5 via this increment. And that's how a for loop works. So let's do another example. This time let's print 1 through 100. Very simple thing. And let's do it by 2s. So we're going to go 1, 3, 5, 7, 9. Let's do the odd numbers, in other words. So we'll wipe this out and start over again rather than try to modify it. So we start with the keyword for, int I equal 1. You'll notice I use I a lot for the loop control variable. That's just a convention or a style. It's not a requirement. Your loop control variable can be any name you want. It is common, though, in for loops to use a single letter variable. Even though when we first started talking about variables, we suggested that you use mnemonic names for variables, and we still believe that's true. But for a for loop, it's okay to use a 1-letter, 2-letter variable name because the loop control variable is always close to where it's being used, and it's easy to remember or go back and look to see what that variable name is for. So we're going to say while I is less than or equal to 100, because we want to print the odd numbers from 1 to 100, not inclusive all the way through 101, for example. So we're going to stop. And here our modification statement is going to be I plus equal 2, which is the reason I use this example, was to demonstrate how the modification part of this for loop can differ from just a simple increment. And then all we're going to do here is write out the value. So we're going to write system out print I, then we close the loop body, save the file, come back to our DOS prompt, and then run it, and there we have the numbers 1 through 99. Just the odd numbers, 1, 3, 5, 7, 9. You see those there. Let's look at one more example. This time I'm going to sum the integers 1 through 10, 1 plus 2 plus 3 plus 4 plus 5. So we'll start over again. Here I need another variable, the sum, so we'll declare sum and set it to 0. And then we're going to say for int I equal 1, I less than equal to 10, plus plus I, sum plus equal I, and write out the result. System out print line, save the file, Let's clear the screen here. Compile and run. And the sum of 1 to 10 is 55. So looking at this program, what's happening is for each value of I from 1 to 10, we're adding it into sum. So the first time through, we add 1 to 0 to get 1. Then we add 2 to 1 to get 3. Then we add 3 to 3 to get 6, and so on and so forth until we get to 10. And that's 45 plus 10 is 55. And then once I reaches 11, 11 is not less than or equal to 10, it stops. And I haven't really emphasized that part of it because I think by now you understand how the relational expression works. And that's all that is, another relational expression. It's just not in parentheses because this whole part is in parentheses. There are a few alternative ways to write for loops. I want to cover those in this lesson. Let's start off with just the standard loop, and then we'll look at those alternatives here in just a moment. Let's begin by writing a program that calculates simple interest again. So we're going to start out with a balance variable. We'll set it equal to 5,000. Another variable for the rate we'll set to 2%. Then we'll write our for loop for int I equal 1. I less than or equal to 10 plus I, then open the body, then balance is times equal the rate. Close the loop and write out the result and the balance. Let's compile and run it, see what we get. Java C chap 9 part 6.java, and then run it, chap 9 part 6. And so the balance is 6,094 with some odd cents. The first thing we can do different with the for loop is put the loop control variable's initialization statement outside of the loop. And I equals 1. Notice that if I do take out the initialization statement, I still have to put the semicolon there because the compiler is looking for that. This is called a null statement, but the compiler is looking for some type of statement there. Now by putting the loop control variable outside of the loop, or at least its initialization and declaration outside of the loop, I've changed its scope so that I can reuse the variable after the loop is over. I haven't mentioned this before, but the loop control variable in a for loop can only be used inside the loop if you declare it inside the loop. That's an example of what we call the scope of a variable, and we'll be talking about that more later in the course. But we increase the scope of a variable, or of the loop control variable, if we move it outside the for loop, or at least the declaration and initialization of the loop. But other than that, nothing changes, so let's compile the program and run it again. Verify that nothing changed, and you see we still get the same answer. The other thing we can do is move the modification statement outside of the loop also, ++I. Nothing really changes here. Notice I don't have to put a semicolon up in the heading because I didn't have a semicolon there before, but I do have to put it at the end of the ++I because it's a statement inside the body now, and it has to have a semicolon at the end of it. But other than that, there's no change in how the program works. The semantics of the program, we've just changed the syntax a little bit. Let's compile it again, and then let's run it. Now, having shown you these two alternatives, there's really no reason for you to ever use them. Having shown you these two alternatives, there's almost no reason to ever use them. You might occasionally want to put the declaration and initialization of the loop control variable outside of the loop itself if you want to use that variable's value later on in the program. However, that will rarely, if ever, be the case. There's really no reason to move the modification statement. And the bad thing about modifying the for loop like this is you make your program harder to read because anybody looking at your loop is going to expect these statements to be in their normal place. And if they're not there, that throws the reader off a little bit in trying to understand exactly what your program does. And one of the things you don't want to do is intentionally make your program hard to read. That wraps up my discussion of for loops before the exercises. We'll do an exercise where we work with for loops later. For my next lesson, I want to talk about ways to end loops early or change the flow of a loop by using two statements called break and continue.